when you have a displacement time graph, the slope of any line on that displacement time graph is going to be your constant velocity. So when we're dealing with displacement and time, and you have a linear function, just look at the first portion of the graph. We have a line there, and when we have a line, this is going to tell us that we have a constant velocity. A constant velocity on displacement time. So at any point along this line here, at any point along this line, whether it's 1 second, whether it's a half a second, whether it's 1.5 seconds, no matter what, it lies on that line. When we talk about the slope of this line, this will give us our velocity. It is a constant velocity, or we could think of it maybe as an average velocity also. It could jigger up and down a little bit. But for the most part, when you have a line, you're going to have a constant velocity there. And how we calculate our constant velocity, or how we calculate our slope defined to us in the algebraic world was delta y over delta x. Our slope in this world is a delta s over delta t, because my y variable is my displacement, my x variable is my time now. So we can calculate a velocity by looking at ordered pairs. This is an ordered pair 2 and 40. This is an ordered pair 2 and 40. This is an ordered pair 0 and 0. So we can find the slope of this line, and when we find the slope of this line, it's going to give me the velocity, the constant velocity. And we can use our delta y over delta x, which is 40 minus 0 over 2 minus 0, or 20 meters per second is your constant velocity along there. It is the slope of this line, okay? And once again, we're looking at delta y over delta x here, or delta s over delta t. And if we also look at velocity as an equation, it is your change in displacement over change in time. Delta s over delta t, which is the same as our slope. Our slope, delta y over delta x. So it's doing the exact same thing. Just trying to think of this into something that you're a little bit more comfortable and familiar with. Okay, so we're looking at different questions here. Okay, different questions. I guess it only went up to 30 in the first one. That's okay. That time too, I thought it was 40. So, work through the equation, or work through the problems here. Okay, if you need to ask questions, okay, if you need to ask somebody a question, that is fine. Compare your answers with somebody, that is fine. And we'll come back to it here in a little bit. Yeah, Drew.
What number does it go down to?
Negative 20.
It doesn't look like it. Well, like, what was it?
it looks like it goes down to -10. Alright, Drew?
Okay.
It might be -11, but -10 is fine.
Displacement is 45. Actually, one goes from 40 to, because those columns are 40 now.
And that's why no.
Alright, let's go through this now. First question asked you, once again, there's algebraic skills here, and there's also scientific skills here. First question asked you, starting at 0 seconds, what is the displacement after 3 seconds? What is the displacement after 3 seconds? So we start at 0. What you're looking for is beginning to end. Where did I start? Where did I end up at? What is our displacement, Katie? 30 meters. Okay, and we can put a positive there if we want to, but it's 30 meters because I started at 0, and after 3 seconds, I'm at the 30 meter spot. What's the velocity after 2 seconds? And once again, now we're going to start talking about velocity. So we're looking at the slope of this line from 0 to 2 seconds. What do you get for the velocity from 0 to 2 seconds, Tess? 15 meters per second. And once again, we can go our delta S over delta T. And what I do is I go through and put ordered pairs in there just to make it easier on myself so I don't have to think so much. Just makes it easier. So my delta S, I am going up 30 meters. And my delta T is my 2 seconds, so I have 30 meters for 2 seconds, so we have 15 meters per second. Make sure you include the units. When is the object motionless? When is it motionless? Ozzy?
When the slope is a horizontal line.
Okay, so what time frames are those?
2 to 4 seconds, 6 to 9 seconds, and 12 to 14 seconds.
That's correct. 2 to 4 seconds, 6 to 9 seconds, and 12 to 14 seconds. Because that's where you're having your horizontal line. So this slope here is 0. If the slope is 0, that means our velocity is 0. So we have a time frame from 2 seconds to 4 seconds that we're motionless because my slope is 0 from 2 to 4. From 6 to 9 seconds, my slope is horizontal, or my slope is 0, line's horizontal. And then from 12 to 14 seconds. So we have 3 different times there where our object is motionless. What is the velocity from 9 to 10 seconds? Okay, so here's my 9, here's my 10. We are looking for the slope from 9 to 10 seconds. And that will give us our velocity. Drew, what's your velocity from 9 to 10 seconds?
Negative 30 meters per second.
-30 meters per second. Once again, we could do our delta y over delta x or delta s over delta t. We have 10 minus 40 over 10 minus 9. Just looking at our ordered pair, so we have negative 30 on top and 1 second on the bottom. So we have negative 30 meters per second. Once again, we are just looking at the slope. Look at your ordered pairs. What's my ordered pairs give me? And what's the slope of that segment then? When is the velocity positive? And what time increments is the velocity positive? Riley?
The slope is going up.
So which time increments is the slope going up?
0 to 4 to 6, and then 14 to 16.
There you go. Why? Because the slope is positive. If the slope is positive, that means the velocity is positive. When is it negative, Ashlyn?
And it's going down.
When it's going down. So what's the time increments for those?
That would be 9 to 10,
9 to 10,
10 to 12.
10 to 12. Okay, so 9 to 10 and 10 to 12, we have slope is negative, so it is a negative velocity. What's the velocity from 14 to 16 seconds, Brandon?
20 meters per second.
20 meters per second. That is correct. Okay, once again, we could do our delta S over delta T. Okay, delta S, I have 30 minus a negative. So I have to watch my negative signs here. We got a little boom ching. So we have 30 minus a negative 10. And then we are going over 16 minus 14. So 30 to minus the negative, it gives me 40 on top, and I get 2 on the bottom. So it gives me 20 meters per second. When is the object at its original position? Liam?
0, 11, and 14.5.
0, 11, and 14 and a half seconds. That's correct. The original position is right here. Here's my original position. When else are we there? We are there at 11 seconds, and we are there at, it looks like about 14 and a half. If you said it's 14.47, I couldn't argue it. Okay? 14 and a half is fine. 14.512, that would be fine. So here's my original position, and I'm at that position at these 2 times. What is the velocity of the object from 10 to 12 seconds? Lucas?
-10 meters per second.
Negative 10 meters per second. Okay, from 10 to 12. So we're going from here to here. So we're looking for the slope, which is once again delta S over delta T. So we have negative 10 minus 10. Watch your negatives. We have negative 10 minus 10. Negative 10 minus 10, and then 12 minus 10. So we have negative 20 over 2. Negative 10 meters per second. What is the displacement from 14 to 16 seconds? Dylan?
40 meters.
40 meters is correct. Okay, from 14 to 16 seconds. So I'm here and I'm here. Okay, and if I want to put a positive, that's fine. So I'd start at negative 10 and I go up to 30, or I can go 30 minus a negative 10. Final position minus the negative, our initial position. So I have 30 minus the negative, which gives us plus 30 or plus 10. So we have 40 meters. What's the displacement from 10 to 12 seconds? From 10 to 12 seconds, Jordan?
-20 meters.
-20 meters. We are going down from 10 to 12 seconds. Once again, we can go negative 10 minus 10. What is the displacement from 0 to 16 seconds over the entire interval? What's our displacement over that entire interval? Liam, what's our displacement?
35 meters.
35 meters. How did you get 35 meters?
Because I have 16 at, you have it at 30, I have 35.
Okay, that's fine. I'm up a little bit higher, aren't I? I take it. My old eyes don't quite see as good as they used
It's
to.
close.
Yeah, it's up a little bit higher. I'd probably go 32, but that's okay. Okay, so initial position to final position, whatever that last ordered pair is for you, the Y value here, I put it at 30. But if it's up a little bit higher and you have 32 meters there, okay, or 33 meters. Next question though is, what is the distance traveled from 0 to 16 seconds? What's the distance traveled? Not the displacement, the distance. Once again, 1 lap around, my distance is 400 meters around the track. 1 lap around, my displacement is 0 meters. My displacement is 30, 35 meters from beginning to end. What is our distance that we have traveled? Brandon, what's the distance you traveled there?
130 meters.
130 meters. Yes, no, maybe so. This side over here. What do you have, Tess? 130 meters. Oh, what you have, Katie? What do you have, Liam?
135, that's.
135, okay. Just checking. Making sure you're just not rubber stamping it through. Okay, I have 130 meters also, but now you're talking about, okay, how far did we travel? Okay, from here to here, we traveled 30 meters. So from this, for this increment from here to here, we went 30 meters. Okay, we are motionless, so we're still at 30 meters here. Okay, then we go from here to here, we go another 10 meters, so we can add in the 10 meters from 4 to 6. Okay, if we go from 6 to 9, we are not traveling any distance. But if we look at our distance that we traveled from here to this distance here, we traveled a total of 30 meters here. So we add in another 30 meters. Even though it's going in a negative direction, we're still traveling 30 meters. Okay, here we're traveling another 20 meters. Here we're staying motionless, and here we travel another 40 meters or 45. From there to there. So we can add up all these distances that we've traveled to get our entire distance that we traveled. Okay, once again, that's the difference between distance and displacement. Questions? All right, this is the last thing we're going to do today. Tomorrow, we'll start looking at what happens when we throw acceleration into it and you don't have a constant velocity. What happens to the graph? Okay, we'll start talking about that tomorrow. Also, I will provide you some homework for chapter 1 because we're starting getting close to the end of the chapter. The homework problems, and what I typically do with the homework problems is you'll get 2 points per problem, okay? 2 points per problem with your homework problems. That will be due the day of the chapter test over this material. So it'll be given to you. You will not have to do it for the next day. You'll have 4 or 5 days to be able to get it completed. All right, questions? QED, as done.